Hi guys, so we'll start this week's. Uh, I don't know. Yeah, I think there are some people here. Gayatri is here. There's not much people today. We'll do a very short session because I'm in a different time zone and it's very late for me to do the session at this time of the night, and so it's like very late in night here in south of Australia. So I'll do a very quick session, and if you have any doubt, um, after that point, you might ask me, but what I'll do is that I'll go through the quiz and see from which topic it is asked. Then I'll cover those topics and give you a hint to solve the assignments. Uh, so yeah, that will be today's uh, itinerary, and we'll be done in about an hour. Okay. So yeah, I'll start in 2-3 minutes. You may. Right then. We'll have a look at the questions. The question number one is, what is primary function of data link layer in OSI model? To provide end-to-end second connection, to establish, maintain, and terminate connection between devices, to regulate the flow of data between sender and receiver, to manage access to physical network medium. Hmm. What is not one of the LS services? Every station connected to an Ethernet network is provided a 6-byte physical address by okay. When two or more bits in the data unit has been changed during the transmission, this error is called okay. Which sublayer in the of the data link layer the functions that depend on type of medium? Okay. I see. So in the past week, we have already been through a couple of OSI layers, and these are the OSI layers and the function that they provide in this network, computer networks and internet protocol while doing computer network. So first is application layer. Network applications such as file transfer and terminal emulation. So, so when you open Chrome browser, the Chrome is basically the application, and the way it makes request or get request or like post a request is post a request is um, different. So I was telling. So the way it send a file or receive a file is treated as the application layer stuff. In the presentation layer, once the data is there, once the request is made and you get back a web page or any video in response, so this is the data. So this is like data, so you have to format it, encrypt them, and so on, just to send it in the network. So this data link, sorry, the presentation layer does that. Presentation layer does data formatting and encryption. The next in our line is the session layer. So the session layer, what actually does is that it establishes and meant is it is used for establishment and maintenance of the system of the sessions. So it will facilitate creating a session, then it will facilitate ending the session and so on. The transport layer is provision for end-to-end reliable and unreliable delivery. The reason we said reliable and unreliable because in reliable we use TCP and in unreliable we use UDP. So that is your session layer. Uh, so that is your transport layer, and it works from one endpoint to another endpoint in the same or different computer. Then there is network layer that we saw earlier as well. Network layer is that connect different networks with each other. So uh, uh, so delivery of packet of information, which includes routing as well. So then in the line is the data link layer, which we are going to learn today as well. So in the data link layer, transfer of units of information, framing, and error control, error checking. So in the data link layer, you actually target a device, device's address, and then you send packet to that. The final is the physical layer. So physical layer is just wires or Wi-Fi wireless mediums uh, where you send data to a particular, so through which the data goes to a particular destination or particular uh, uh, router, right? Uh, this is a way how data transfers between two devices, and given that there are some intermediaries sitting in between. So first, let's say device one and device two are in the extreme left and the extreme right of this figure. So so your there is a computer in the left. The computer has every layer in it. Starting from application layer, you have network transport layer, network layer, data link layer, and physical layer. But when you transfer the data from this computer to the next switch, so switch is a layer two device. That means only physical layer and data link layer is there. It cannot do routing, so it will just take in the packet and send it to a near routing um, device to facilitate routing. So that is your switch. The switch has a layer 2 device. That means when the packet reaches, it will read the physical layer content header and the data link layer header, and then it will after after finding this data link layer and physical layer, it will start to um, also, yeah, so after finding all these things, it will start to mm, uh, forward the packet to the next device, which may have a data link layer, may have a network layer, or may have any everything. So in this way, it will go to the second next switch and finally to the computer. So there's a difference between OSI and TCP/IP model. So in OSI model, just not much. So in the OSI model, this presentation and session layer is squeezed into application layer, and everything else is the same. Okay. Okay. So then the data link layers um, working. So data link layer is divided into two layers. One is medium access control layer, and the second one is logical link control layer. So the logical link control layer uh, facilitates the transfer of file between devices, and the medium access control MAC layer uh, facilitates access of a wire. Like if the wire is free, if the wire is busy, should I send it now? So MAC layer sort of decide how to send, and LLC layer decide where to send. Okay, so there's that. Let me see if I have covered any questions so far. Okay, so question number one is covered. The primary function of data link layer in OSI model. It should be either C or D. I cannot give you more hint than this, but should be either C or D. It can be used to regulate flow of data between sender and receiver. It can be used to manage access to the physical network medium. So I'll not tell the exact answer, but yeah. Okay. So there is that, and the second is next we'll go to the data link layer in detail. So this is your network layer, and this is your data link layer. And the top part is logical link control sublayer, and the bottom part is medium access list sublayer, that is LLC layer and MAC layer. So why do we need LLC layer? Why do we need MAC layer? So let's say there is two computers here, and one and two. They learn how to connect. So let's say you have a wire to connect them both. So what you can do is that you can connect a wire. But what if there are more hosts? Okay. What if there are more number of hosts? What you can do is that you can assign everyone to a switch. Okay, and each switch will have two connections. Okay, and not each switch will have two connections. Like everyone is attached to the switch, and the switch are connected with each other to communicate. And this is one way to achieve to get in touch with everyone. The second way is you put wires for everyone. So if there are n hosts, you put how many? So if there are like three hosts, you put wire between everyone to everyone. So there will be a total of three. If there are four hosts, there will be a total of six wires. Okay. How to calculate how many wires will be there? So it will be um, n into n minus one by two. Okay. So uh, yeah. So the issue two is so what sharing of wire is necessary, right? You have to share the wire before you speak anything or start anything. So you have to share the wire. And we cannot do wire for everyone to everyone because it will be too much. So we have to share the wire. And once we start sharing the wire, we will face problem. The problems that we will face are like first is listen before you speak. Like if someone is saying something and you have to listen, um, because I mean yeah. So, so there are like issues of link layer. Issue two is listen and speak. Uh, like with if everyone is so if you say listen before you speak, so you listen, there is no one is communicating, so this wire should be free for someone to communicate. So if the wire is not free, you cannot communicate, right? So what they are doing is that they're listening. If the wire is free, they're communicating. Listening, if the wire is free, then communicating. But what if they listen, the both party listened that the wire is free, then they started to communicate at the same time, then there will be a collision, right? So if two people are speaking at the same time, there will be a collision. So this is called so, and in data link layer we do collision detection and collision control and collision avoidance. So first we detect collision and try to resolve it, or we just avoid collision by not transferring at the same time. Okay, so if we have to do that, okay, so that's the second issue. The third issue is the recipient of the packet. So if there's a packet and you want to send it to a different system on the same LAN, you need to put an address on the packet, right? So if you want to put an address in the packet, what should be the format? And how do you know what address do you want to send it to? Okay, this is the issue number three. So to solve all this issue, we have MAC, that is medium access control. Medium access sublayer is primarily used in broadcast or shared channel networks. And MAC protocols enable two stations or nodes using a shared communication resource to establish, maintain, and terminate a connection. For example, satellite, Ethernet, and cellular. So this is the MAC IEEE 802 standard. So since all this data link layer and all this there were physical, it was bounded by this IEEE 802 standards, which give a standard that how this layer should operate and how do they communicate. Because the standard they started the standard because if a company is manufacturing something that should be used to be able to use by everyone who is using that as a product, not only the product from that company. So that's why there is a standard. There is data link layer, physical layer, and in the data link layer there is LLC sublayer and MAC sublayer. The protocol uh, uh, that governs this is Ethernet protocol, and the LAN specification is given in this site, like IEEE 802.3 that created CSMA CD, then IEEE 802.4 that created the token bus, then IEEE 802.5 that created the token ring, and ADDI, and finally IEEE 802.2. So 802.2 started the logical link control, the LLC, and then 8.3 started CSMACD, 8.5, 2, sorry, 802.5 started token ring, and 802.11 started wireless LAN. This is the same thing. So, yeah. So the 802 layer function is functions. Also 802 layer function. So in physical layer, we do encoding and decoding, um, preamble generation and removal. Preamble is just like start frame and the end frame. And third is your bit transmission and reception. Fourth is transmission medium and topology. In the logical link control, we have interface to higher levels, then flow and error control. And in the medium access control, we have data assembly dismantle into frames, then govern access to LAN transmission medium. So this I already discussed, I guess. Scope of LAN protocols. The scope of LAN protocol is two stations, like A and B, that communicate via a shared medium. Then higher layer above LLC provide end-to-end services between the stations. Below the LLC layer, MAC provides the necessary logic for gaining access to the network. So it's just saying how this the scope of LAN protocols. The logical link control, or the LLC layer for LAN, is connected with the transmission of a link level protocol data unit PDU between two stations without the necessity of an intermediate switching node. Two characteristics: it must support the multi-access shared medium nature of the link. It is relieved from some details of link access by MAC layer. So it's asking this question number 2, what is not one of the LLC services? We saw that LLC layer for is connected to transmission of link is concerned with the transmission of a link level protocol data unit between two stations without the necessity of intermediate switching node. So connection and mode service is a service. Acknowledged connectionless service is not, I guess. C, intermediate switching service is LLC service. Unacknowledged connectionless service. Let me see. And the LLC services that you saw here, acknowledged connectionless service and acknowledged connectionless service, both unacknowledged and acknowledged is there. So that means this and this are LLC services. Intermediate switching service or connection mode service might be the answer, but I'll not tell you that. So yeah. So question number 2 is done, I guess. I have given enough hint. You can, I think, figure out if it is A or C now. Okay, so whenever you buy a Mac, sorry, when you buy a computer or any device that has layer 2 switching and that has that is a layer 2 device, so the company firmware will give you a 6-byte physical address, and that is called MAC address. That means, so similar to your IP address or port number, each device in the data link layer that has a data link layer has a MAC address. So yeah, so that there goes the MAC address, and I think you can answer the question number 3 now. We'll move on with our discussion with medium access controller MAC. Assembly of data into frame with address and error detection fields. Disassembly of frame and performing of address recognition and error detection. govern access to transmission medium. For the same LLC, several MAC options may be available. Then our medium access control. So all LANs consist of a collection of devices that must share the network's transmission capacity. Function of a medium access control protocol. Uh, some means of controlling access the transmission medium is needed for efficient use of capacity. Key parameters in any MAC techniques are where and how. Where refers to whether control info is exercised in a centralized or distributed fashion. So centralized means a controller has the authority to grant access to the network. Distributed is a station. The station collectively perform a max function to determine dynamically the order in which stations transmit. How is how that is constrained by the topology and trade-off among competing factors such as cost and performance and the complexity. So LAN protocol messages. So there is your application data that is coming down and getting a TCP header here. Then it is coming down, getting a IP header here. Uh, then it is coming down and getting an LLC header here. Then it is coming down and getting a MAC header and MAC trailer here. Okay. So LLC is the link. So in the data link layer, as I said, there is two things. One is LLC and one is MAC. So first you have to put the LLC header. Then you have to put MAC header and MAC trailer. Then only you'll get a full MAC frame. And that MAC frame will be passed on to the physical layer where we will put preamble in the start and end of the byte, then we'll send it away. Okay, this was all about this. Then we'll look at the logical link control. The LLC layer for LAN is concerned with the transmission of a link level protocol. Data unit PDU between two stations without the necessity of an intermediate switching node. I think I have covered that. Okay, so I think this we have covered. Assembly of data into frame with address and error detection field. Disassembly of frame and performing of address recognition, error detection. Govern access to transmission medium. For the same LLC, several MAC options may be available. Then generic MAC frame format. So let's just see like how the MAC frame looks like. So first is MAC control. This MAC control contains control info for functioning of MAC protocol. For example, priority level, destination MAC address, the destination physical attachment point on the LAN for this frame. Source MAC address, that is the source physical attachment point on the LAN for this frame. LLC is the data from the next higher layer. So PDU is the payload. So LLC data from the next higher layer, and CRC is the cyclic redundancy checklist check field used to check if transmission error has been occurred. So CRC is used to check the transmission error. CRC is CRC checksum. We call it CRC checksum. You can also call it as CRC. So this checks that. There is MAC synchronization. So MAC techniques. There is synchronous MAC techniques and there is asynchronous MAC techniques. So in the synchronous, a specific capacity is dedicated to a connection. Same approach as in circuit switching, FDM or TDM, not so optimal for LANs, MANs because the need of stations are unpredictable. Asynchronous is capacity is allocated in dynamic fashion and the response to demand. Subdivided into three categories: round robin, reservation, contention. So the thing is that yeah, so the thing that we learned here is how I don't know how this content is so scattered around different topics, but the thing is that when we generate a MAC, so this is when we generate a MAC packet here, We have to attach all these fields before sending it, and this is the format. This is the header of the Mac frame format. Like this is the format of Mac header. Okay, this is for Mac header. And what it is saying the next is how Mac actually handles this. How Mac actually handles this. What how Mac actually handles this conversion of. I mean, bit sending a packet to the channel. One is synchronous way. Synchronous means you will be given a time frame, and you can send in the time frame or send in the frequency range, so that the receiver will receive. Asynchronous is it is a bit dynamic in fashion. It is subdivided into three categories: round robin, reservation, and contention. So we'll learn about that in a while. So round robin is that each station in turn is guaranteed to write to transmit. So each station will be, say, like if there are like 10 system connected through a LAN, so each one will be given some time to transmit. If they have to transmit, they can transmit in their time period, and if they have to not, if they have not anything, to go to the next one, and if they have something to send in between, they can wait for the next round. So after each station finishes transmitting, it passes the right to transmit the next station in the logical sequence. Efficient technique when mesh efficient technique is the efficient technique when many systems have to data to transmit over an extended period of time. The second is reservation for stream data, traffic voice, stream traffic such as voice and bulk wire transfer. Time on the medium is divided into slots like synchronous medium. A station wishes to transmit reserve slot for the extended period of time. So let's say uh, uh, yeah, let's say I want to transmit something. I have a file that size is like this, and let's say I need this much amount of time to transmit. I'll just I'll just wait. I'll just block that time period in the wire, and I'll send that uh, uh, file once in a while, once at once um I'll send that file at once. Third is contention for bursty traffic. So no control is exercised to determine whose turn it is. Simple to implement and efficient for light loads. So there are three types of uh, thing that we use to transfer files into the wire. So what is the disadvantage of round robin? Let's say, let's see. In round robin, what if a lot of people doesn't have any data to send? What will happen that will go to them and will dedicate them some time period to send the data, and let's say they do not send, it's just a waste of time because everyone else is waiting and they don't have any data to send. That's a waste of time. Second is reservation. So what if there's a huge data to be sent, so you reserve the traffic for a large for a extended period of time, then you send the data and everyone else is waiting for to send the data, and it is just delayed. Okay, the third is contention. Contention is no reservation or nothing. So in that way, there will be a lot of collision and collision between two parties sending data, and there will be a lot of data loss, and there will be a lot of error in the data, and you have to do a lot of retransmission as well. Okay. So this is the the traditional way of sending and asynchronous back technique. Now we'll see how we can send this if these methods are failing. Like what is this? And the method used for CSMS medium access controller, CSMSCD, and the second is token control token or token passing or bus and ring topologies. Control token or token passing for bus and ring topologies. I'll discuss that in 3 minutes. Let me get back in 3 minutes. Yeah, I'm just checking for water. Just 20 minutes. I'll be done. Alrighty. So, okay. So first is CSMACD. So what they're saying is that we cannot do all these things. What we can do is that we can first send, like if I have a data and I am a computer, I'll just send. If it is, if it detects that something is in the network, okay, something is in the network, it will stop transmitting. So if it will detect collision, it will retransmit that again. You get that what I'm trying to say? So first you send, then you experience a collision, then you send it again. Okay. So you experience a collision and you send it again. So so I'll tell you, and CSMACD is like CSI says there is CSMACD, and there is control token or token passing. So if you want to, so there will be a token rotating across the channel. If you want to send, you'll just catch the token and send it, and till the time you release, if anyone else want to send, it will wait for the token to come to him, and it will send at that point. So, okay, so we'll start with the CSMA city. CSMA city is used only in the bus type networks where a number of nodes share a common communication channel known as the bus. And CSMA city is used in traditional internet. So, CSMA city is short for carrier sense, multiple access, collision detection. Okay. So carrier sense means so you have, okay, let's see, you have four computers, A and B and C and D. Carrier sense means you sense the carrier first. Okay, you sense the carrier that if it is free or not. Okay, you sensed it and you found that it is free. Then multiple access. Multiple access means that A and B both sense the carrier, and for A and B, the sorry guys, yeah, yeah. So for A and B, the for both A and B, the carrier was empty. So A and D. So A and D start to transmit to the wire. There is multiple access, multiple parties are accessing the same wire again and again. So what will happen is that there will be a collision, right? If A and D sends the data at the same time, there will be a collision. So there is a collision and there is a collision, and the CD is collision detection. That means you detect the collision. That you detect the collision. Uh, so when you detect the collision, so you use the backup algorithm to roll back what you have sent. Then you send it again, retransmit. Okay. So I'll just read this CSMA CD procedure, and you'll be able to understand, I guess. The basic operation of CSMA CD is as follows. To transmit data, the source station assembles a packet comprising, com, comprising of destination address and data and control info. That is pretty basic. The source station listens to the cable to determine if the bus is currently in use. So what I said here, it will first listen. If so, it waits until the bus is free, else it transmits the packet. The operation is called carrier sensing. Second is, during transmission, the source station continues to listen the cable to detect if another station has also initiated transmission, thus causing a collision. This process is called collision detection, as I said. So if uh, if you listen here, you'll know that okay, there is another signal as well. So the third is, if the collision is detected, then to ensure all stations are aware of the collision, the source station transmits a random bit pattern, also known as jam sequence. So you can see here jam sequence. You detect that collision is happened because you are seeing other uh, things as well, and you put on the jam. So whomever from A and D detects it first, it will initiate a jam sequence. That's a random pattern, bit pattern, and I think known to everyone, the jam sequence. The station involved in a collision then back off for a random period before retrying for a before retrying for packet transmission. So the stations who are involved, like A and D, will back off. Then they will wait for random period, and then they will start transmitting again. So this is like one of the flow charts you can refer. So like start, set backup to 0, persistence strategy, send the frame, collision, no, success, yes, send jam signal, increment backup limit, yes, abort, no, wait for backup time, and send again. Collision detection, in other hand, is so there is sensor panel. If idle, transmit immediately. If busy, wait until the panel becomes idle. Collision detection is abort a transmission immediately if a collision is detected. Try again later after waiting a random amount of time. Okay. Collision detection time. How long does it take to realize there has been a collision? So the worst case is two into end-to-end propagation delay. So that means, let's say station A and station B is at the extreme end of the bus, okay, and station A starts a packet, and before station B starts the packet, the first bit of station A reached station B, let's say. So the first bit reached station B, let's say, and the collision happened at station B. So if the collision happens at station B, for the jam signal to reach station A, it will take it will take one T prop, that is T propagation time. Since the packet has been sent and it has been traveling for one T prop time, the total time it will take to detect the collision after station A starts transmitting is 2 times the transport two times the propagation delay, that is one RTT or one round trip time, or or two end-to-end propagation delay. Then the next method, I think it is the last method today, is a control token or token passing. Another way of controlling access to a shared transmission medium is by control token or token passing. The control token technique uses a controller permission token to share the communication resource between a number of nodes. The technique can be applied to both bus and ring topologies. Okay, this is a new thing. It can be applied to bus as well as the ring topology. So this token is passed from one system to another according to a defined set of rules. A station may transmit a frame only when it has position of token, and after it has transmitted the frame, it passes the token on to allow another station to access the transmission medium. Control token operation. Whether using a ring or bus topology, a logical ring is established which links all the nodes using the physical medium. So if it is a ring topology, the token will rotate across the ring. But if it is a bus, a logical ring is established and which links all the nodes using the physical medium. Um, so if it is a bus, so there will be token generated at each time frame and it will be propagated through the bus. Then again, a new token will be generated in one end and it will be propagated back to the other end. A single control token is control token is created at one of the nodes. If token passed from node to node around the logical ring until it arrives at a node waiting for to send a frame, the node captures the token and transmits the frame. Upon completing transmission, the node releases the token to the next node in the logical ring. So this is a token passing network. A token always circulates around a ring net, and a user grabs a token to transmit data. So user grabs a token, then transmit data, and so on. Uh, there is control token procedure. It's just a flowchart. You start, you wait for the token, capture the token, data frame to send. Yes, send a frame. Allocated time expired. Yes, replace the token. Stop. So the data frame to send. No, release the token. Stop. Then allocated time expired. If it is no, if you have a data frame to send, yes, you can send. Let's say you have got token for 30 seconds and you transmit your data for like 10 seconds. Then it will ask, do you want to transmit the data again? And do you have any other data to send? Like if you say yes, then it will allow you to send till the next 20 seconds. If you say no, it will abort. So you see the difference between this and the round robin. In round robin, yeah. So in round robin, it was in round robin it was capturing it was giving like 30 seconds to each of them to transmit. If you are not transmitting, then it was just discarding. Then it was not doing anything else. But here, what you can do is that you can transmit, uh, and if you're not transmitting, the 30-second will not be waste. It will be transferred to the next user to transmit, and you'll be fine. The next is LAN addressing. So I think we have done till token ring as well. Let's see how many questions we have covered till this. We have questions covered till 3. Uh, when 2 or more bits in the data unit has been changed during the transmission, the error is called burst error, maybe. Yeah. Which sublayer of data link layer performs data link of functions that depends upon the type of medium? I think I have discussed it. This medium access control or logical control sublayer, I think it will be one of these two. So you have to figure out. I'll not tell the exact option, but it will be one between A and B. I have already discussed it. Um, Question number 6, in carrier sense multiple access collision detection, the sending station must detect A is collision, B is signal, C is sense, D is station. The sending station must sense. So as you see here, I saying here, these guys are sending data as well as sensing, so that they can detect collision as well. So there's that. In go back and ARQ, if sequence is separated by 4 bits, the sender receiver interface should be. So yeah, so I think this go back and is from transport layer, and I think they added the question here just to check your understanding of transport layer as well. But I don't think it should be covered here in this week. So that takes 7 and 8. Question number 9: a network using Sesame City has a bandwidth of 10 Mbps. If the maximum propagation time, including the delays in the devices and ignoring the time needed to send a jamming signal, we see later, as you see later, is 20.5, 25.6. What is the minimum size of the frame? So it is saying is that what it is saying is that the speed is 10 Mbps and the maximum propagation time is 25.6. So if the two computers stay the two extreme end, it will the two into propagation time is 25.6. I mean the total propagation time is 25.6 microseconds. So if you send a packet, if you have a connection speed of 10 Mbps, you can you can find out what is the minimum size of this frame. That is, you have to divide 10 Mbps by 26.5 microsecond, and you have to scale it down to one digit, like 10 into 10 to the power 6 byte per second, and 25.6 into 10 to the minus 3 uh, second. So minus, and it will be 10 to the power 3, and you can solve it. You'll be fine. And question number 10 is again go back in, which is transport layer thing. So I don't think we have anything to cover here for that. We covered LAN addressing is by MAC. Yeah, so levels of addressing. Yeah, so I think this completes a lot of things. But apart from this, there are other things as well. Shared access network, uh, random access network protocol, Aloha, and all these things. But I'll not cover this because once we don't have any time, it's already 10:30 here in Melbourne. So due to the chat time zone, I will not be able to cover it. Second is that there is no question that is related to this, so there is no point in discussing all these things again and again. If you want to see this, you can go to the lecture, I guess, yeah. But if you solve that question, that will be uh, good. That will be good on you. Like this question number 9. But if you're not, I think I have discussed a lot. I think I have discussed a lot uh, regarding um, CSM and CSM. I might see this one collisions. Okay, collision detection. Yeah, so I already said it. Said it takes two into propagation time. This is the backup algorithm. We are not covering the backup algorithm because it is not needed in the um, questions. But anyway, Ethernet collision detection. Yeah, is a way to find the Ethernet address, evaluation addressing and stuff. There's a lot. There's a lot. Okay. So, okay. But we will end the session here in some time. So, yeah. Thank you for joining. We'll see you next week. But yeah, we have to end the session here because the time journey is a bit um, uncomfortable for me. I'll see you guys next week. Thank you for joining. You can drop off now if you like.